Okay, so jumping right back in, for problem number 3, it says use an appropriate identity to solve. Well, sometimes you have options, this time you don't. Pi over 8 can only be solved through the lens of a half angle. So I want to think of this as the cosine of 3 pi over 4 cut in half. So we need to come over here and use that identity, which is the 1 plus the cosine of whatever angle it is divided by 2. But in case you didn't catch that, the angle that I'm going to be referring to is that 3 pi over 4, because I don't know how to do 3 pi over 8. Now, I know then that if I have the cosine of 3 pi over 4, that's a fairly simple one to do. We've done that a few times. I know that I have 1 plus, this is going to be a negative root 2 over 2 inside here, because the cosine of 3 pi over 4 is negative root 2 over 2, because this is in quadrant number 2. However, we're going to do one more thing, which is I'm going to multiply the top and bottom by 2, and I'm going to have a square root of 2 minus root 2 inside there. And again, just like that previous problem, when I multiply by 2, I get a 4, but the square root of 4 is 2. Now, I haven't mentioned the plus or minus, so let's make sure we finish that. 3 pi over 8 is actually a simple little angle that's just a little bit less than 4 pi over 8, which would be pi over 2. And so I know it's in the first quadrant, so I know that my answer should be positive, and I'm done. Now, again, check your answers on your calculator, and you're good to go. So last one of these on this page is, again, let's use the tangent of 7 pi over 4 cut in half. And keep in mind, I'm not wanting the tangent, I'm wanting the cotangent. So what I'm going to do is I'm actually going to change that over to a cotangent, and I'm going to take the identity that I gave you and I'm going to flip it over. And I know that the cotangent would be 1 plus the cosine over the sine of that half angle. And so if you look at the identity that you have, you're going to notice that I've already flipped it over because it's not a tangent, but a cotangent. And so again, even though this one was in the second quadrant, this one is now in the fourth quadrant, and that matters. So that's going to make the cosine positive. It's going to make the sine negative. And I'm going to multiply everybody top and bottom by 2 to make life a little bit better. And if you got here, I think we're good to go. But as it turns out, we can do one more little thing. 2 divided by root 2 is actually root 2. And root 2 over root 2 is 1. And so that's actually the optimal solution, because it is, again, the simplest. So that's number 3. I'm just going to finish up number 4 on this video, and then we'll jump to the other ones. So moving to number 4, we actually jump back to this idea of having multiple triangles. And this is going to be a harder problem. Now, I know automatically that pi over 2 is right here. That's what we have. And pi, come on, you're good. And pi is over here. And so I'm telling you in code to put the triangle in the second quadrant. Now, the reason I chose to do that is because of something else. Back from Algebra 2, if you were to take and divide every single piece of these by 2, then what I could say is that beta over 2 is somewhere between 45 and 90 degrees. This means this is in quadrant number 1, even though beta itself was in quadrant 2. So the cosine is here. We're going to do just a real quick Pythagorean theorem on that, and we find out that this thing, oops, did I do that wrong? No, I think I'm good. So I've got the cosine of beta is negative 8/9. And that's going to leave this with a root 17. I wish I'd done alpha first, but it's all right. Well, I just have to make sure that I go back and forth. And then this tangent and the sine are both positive, so it's a 5/12 and 8/13, which is one of those that we've seen. So I'm going to be really careful because I did them a little bit out of order. Now, for the cosine, we actually had 3 options to choose from. So I'm going to grab this card that I use a lot. So I know the cosine, I could use any one of these 3, but since the problem actually gave me the cosine right here, I'm going to use the cosine identity. And it was about beta, not alpha, so let me fix that. Beta minus 1. So 2 cosine squared is minus 1, where the cosine was a negative 8/9. And that's going to come out pretty nice. Just use a calculator real quick. You're going to get 47 over 81, or if you want to square that, you can do that too. Now, again, over here, the sign of beta over 2, remember, was plus or minus, but that's why I did this little step here to establish that it was in the first quadrant, so it's going to be positive. And so now let's just finish it off. 1 minus the cosine of beta, which was negative 8/9. And that comes out pretty good because if I multiply the top and bottom by 9, I get root 17 over 18. And we could stop there if we wanted to, but if you did a little bit of work by multiplying the top by 2 and the bottom by 2, root 34 over 6 is a much nicer answer, but I would have been okay with this one. So keeping moving on just a little bit more, the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. A lot of stuff there. And now we just have to come in here and find those values. But I got to be careful because, like I said, I accidentally wrote mine out of order there. So the cosine of alpha was 12/13. Got that one here. The cosine of beta was the first triangle. That's a negative 8/9. The sine of alpha was 5/13, going to the right triangle. Here, the sine opposite of hypotenuse. And then the sine of beta was opposite of hypotenuse, which is here. And something that's really, really nice that happens in these problems, you notice we have a common denominator, don't we? So we've got a negative 96 on top, and we've got a minus 5 roots of 17 on top, and we are done. Now, last one, and then I'm going to stop this video. We have this little identity right here. Understand, make sure that you understand I'm using the alpha triangle this way. I just literally wrote it down because it was easy to do. There was 3 identities. I just picked the one that I liked the best, which is 1 minus cosine over sine. The other ones would lead to that same answer, but the cosine of alpha is 12/13. The sine of alpha up here up top was 5/13. So if you multiply the top and bottom by 13, you get a ridiculously simple result of 1/5. And that's the end of our story. So that's the end of that portion of the review, numbers 3 and 4. Hope that helps. See you back in class. Okay.